Hello, I'm Sean Buckley, Editor-in-Chief of Broadband Technology Review. Today, I have the pleasure to be joined by Steve Condra, Director of Engineering and Product Management of Teleste Intercept. Welcome, Steve.
Thank you. Thank you for being here, and I really appreciate your time today.
Great, same here. We're going to discuss a few things here. First one is to talk about the evolution of network intelligence in cable networks, which is an exciting topic. And to start out with, I want to ask you, how has the evolution of network intelligence over the past 15 years transformed the approach of cable operators towards network management and optimization?
Yeah, thank you, Sean. This probably started a little bit more than 15 years ago now. At least this journey for Teleste started at that time with the consolidation of cellular companies and cable TV companies in Europe. And as those companies consolidated in Europe, we got requests from customers to make the operations of our outside plant equipment similar to the way cellular equipment is used, so that they could move their operations people back and forth between networks. And they were trying to get away from the large amount of RF training and RF expertise required in the cable TV industry, and then be able to use their resources across multiple platforms. And so that created an opportunity for Teleste and other manufacturers to start to automate some of the processes that occurred either during installation or during operations or during troubleshooting of the network, and make those items less excuse me, less dependent on a vast expertise in RF and RF design. And so we were able to do that over the course of many, many years of small improvements and create some products that introduced intelligence into the cable TV business.
Yeah, one of those themes I know that Teleste is really big on and is really pursuing aggressively is intelligent amplifiers. Let's talk a little bit about that and what influence that has on the cable industry.
Yeah, so we actually have broken the intelligent amplifier kind of into three parts. There's what we call a smart amplifier, and what a smart amplifier does is it introduces microprocessors into the amplifier for some onboard calculations that enables measurements to take place locally at the amplifier, and then use those measurements to create automation to make the job of the installer or the operations technician easier. Our next category of amplifiers is what we call a connected amplifier, and that's one that has a communication channel between the amplifier and the head end that allows the technician to see either alarms or measurements from the head end without getting in a truck and making a truck roll. And then the third category is when you combine a smart amplifier, a connected amplifier, with software back in the head end, that starts to create what we call an intelligent amplifier. And that's one that combines the intelligence that's in the amplifier with the connection to the head end, and then software back in the head end that enables you to automate many of the processes for both installation and operations of amplifiers.
Right. So basically the operational benefits for each category to operators is, again, more efficient installation and, better, I guess, kind of visibility into kind of how the health of the network is kind of functioning. Yeah.
Yeah, so that's a great point. And part of it is to reduce the amount of tools required by, say, a truck roll or a RF technician, where he doesn't have to have RF expertise to plug in pads and EQs. He doesn't have to necessarily even have a meter. He can get some basic measurements from the amplifier itself, whether it's voltages or RF output or slope, and he could also see alarms. So if you can reduce the amount of equipment required by the technician to go to the field and either detect or diagnose or install an amplifier, and make that a more seamless operation, it helps everybody.
Now, how important is this going to be as the large cable operators and the smaller ones, make their ongoing migration to DOCSIS 4.0? I mean, so they can deliver 10 gig services. I mean, how important will it be to have these kinds of elements in the network to make that transition?
Yeah, that's a great question, and one we are getting ready to install a cable TV network today that has as much bandwidth as in the upstream as we used to have years ago when I started in this industry in the downstream. So if you think about that for a moment, when we were back multiple decades ago, where we had maybe 550 or 750 megahertz of downstream spectrum and 42 megahertz of upstream spectrum, then it was more of a broadcast network with a little bit of internet data on top of that. And that's the way that network started. Now that we're getting ready to have 1.8 gigahertz of downstream spectrum and maybe up to as high as 684 megahertz of upstream spectrum with 1.8 gigahertz downstream, then we're now more of a symmetrical bidirectional network and moving away from a broadcast only network to a telecommunications pipe, if you would. It makes the RF circuitry much more complex, because now we have to not only take care of the downstream signal levels and signal slopes and changes in temperature that happen in the outside plant for downstream, we have to do the same thing in the upstream. And doing that in a way that makes it seamless for the operations folks and easy to understand and easy to diagnose, that's the power of intelligent amplifiers.
Right. So let's talk about the strategies for leveraging network intelligence. I mean, considering the imperative to harness intelligence within networks, as you talked about, is now more pressing than ever. What strategies should operators employ?
Well, so what we like to do is make at least demonstrate the feature capability of and the measurement capability of both the amplifier and the software. And we feel strongly that the best way to implement and execute that is to really get close to the operations people in the field. And if we can make our products seamlessly operate with the processes that already exist in the field, with how they detect alarms and how they get notified for alarms, to how we proactively notify them before there's an alarm, or proactively give them an alarm before there's an outage, that's where they get the real power of intelligent networks. And one example that I can give you is ingress, which is a big issue for the industry, where there's normally a upstream ingress issue that starts to create noise floor, and at some point can disrupt the upstream signals enough where it can take certain cable modems either to a degraded performance or a total disconnect. And we have the ability to detect that ingress before it gets that bad, number one. And number two, also pinpoint where it's coming from. The biggest issue with ingress today is you know it's happening, but you don't know where it's coming from. And so it's very much, in the past, has been a needle in a haystack searching, where you start at the head end and you work your way out and with lots of measurement equipment and lots of bucket trucks if it's aerial plant, and where you're looking for that ingress. And many times what happens is before you find it, it disappears. So ingress sometimes is not constant. It changes with time. And so that's hugely frustrating for the operations folks. So one of the things that we've done is we've built in measurement detection and attenuation switches that allow us to find out exactly not just which node, but which amp or which port off an amplifier the ingress is originating from. And now we can surgically dispatch people to say, okay, we know it's on this road between the fourth house and the seventh house down, and that's where to go look for the ingress. And now we have a much better chance of finding it before it disappears and actually fixing the issue. In addition to that, we also have mitigation techniques we can use in the amplifiers that enable the system or the network to maintain connection to the cable modems, even in the even in the face of rising ingress or rising noise floor. We can attenuate some of those signals in certain spots and enable that it's not going to take a customer offline. So those are huge issues where you prevent an outage, number one, and number two, you find the root cause in a few minutes instead of a few hours. So
Yeah, all about that visibility. Great.
yeah.
Well, thank you, Steve. If I could just get a couple final thoughts, and then we can wrap up our talk here.
Okay.
Pleasure talking to you. Yeah.
No, we're very excited. It's a I wouldn't call it a once in a lifetime, because maybe this is at least my second time of in a lifetime. I'm giving away my age a little bit, but second time in a lifetime of doing a pretty substantial network upgrade of outside plant assets. And it doesn't happen very often. And so when it does happen, you want to make sure that you use the best technology, the highest reliability, and build in as many future-proof aspects when you're out there doing these upgrades. And so these opportunities don't come along very often. And we're working real hard to make sure that we make available the best technology to make not only the seamless operation to get to a DOCSIS 4.0, but also improve such things like power consumption, reduction in power consumption, as well as greatly reduced operating cost.
Right. No, that's some great stuff, Steve. I'm looking forward to hearing more about it as the industry continues to evolve. Like you said, it's a real exciting time. Again, this is Sean Buckley, Editor-in-Chief of Broadband Technology Review, and I've had a real great pleasure to speaking to Steve Condra, Director of Engineering and Product Management at Teleste Intercept. And thanks again for your time. It was a
Thank you,
great
Sean.
talk.
I appreciate it.
Thank you.